I wanted to teach you another way to find the vertex, which is probably the easiest way of doing it, which is by using what we call the vertex formula. Basically, it's just a formula which has the location of the vertex solved based on A, B, C in standard form. So if you ever had a quadratic function in standard form, you could always find HK and thus convert it to vertex form by simply using this formula. So basically, this would be the same process as completing the square or as graphing it. So basically, here's another way you could find the vertex. And let's just go ahead and do it for our previous examples to make sure that it works. And then actually another shortcut, because like one of the weaknesses of this method is, well, first of all, you would have to know this formula or have it memorized. And there are some tricks to memorizing it related to the quadratic formula, which I will probably review in our live class this week. So anyways, I don't want to get distracted. But an easier way to remember it is if you actually just remember the x location, remember that the y location, as I said over here, is just the function value at h. So sometimes another way the vertex formula is presented is that the x location of the vertex, which recall that's the axis of symmetry, is going to be at negative b over 2a. And then the y location will be evaluated at the function f of b of negative b over 2a. Because this must be h, the location of the vertex. And so the height point, since it's part of the graph, must just be at the functional value at that same point. So I know that I'm saying this in a little bit of a confusing way. Basically, if you figure out what negative b over 2a is, plug that into the function, you can find k, instead of remembering this whole formula right here. And also this implies that the axis of symmetry is always at the location x is equal to negative b over 2a as well, because as I said, the axis of symmetry always passes through the vertex for a vertical parabola at least. And it would be at that location. So last thing I want to do is show you, well, let's make sure this works. For each of these three examples, we found the vertex by completing the square, and in this one, we even graphed it to make sure. Let's just double check, let's verify using the vertex formula to do that. And I'll show you those two ways I specified by using the full formula, first of all, and secondly, by using the other shortcut I was just mentioning. So if we wanted to solve the vertex here, we could use the formula. I'm just going to copy it down right here. Negative, oops, I don't have my pen active. Negative b over 2a, comma, 4ac minus b squared over 4a. And if you're wondering how I have that memorized, well, I'm a math teacher, but if you know the quadratic formula, it's very similar. And I'll mention that in live class. But basically, I have it memorized, cool. And so knowing that, I could take the original coefficients from standard form a, and remember, if there is no number, a is always 1, not 0, because technically x squared has a little secret 1 there, not really secret, but if it doesn't have a number coefficient, that's always 1, because when you have 1 just there, that's one of them, right? X squared is 1x, it's not 0x. 0x is nothing, it would be 0. So summary, a is 1, b is 4, c is 5. So we would have negative b is 4 over 2a, and a is thankfully 1. And for ac would be 4. What I like to do is do these all at once. 4 times a is 1 times c is 5. 4 times 1 times 5 is 20. Minus b squared is 4 squared is 16. And that's all over 4a, which again, a is 1. And so what that would leave us with is negative 2, comma, and this would be 4 over 4, and 4 over 4 is of course 1. And notice what we get is the vertex negative 2, comma 1, which is the same thing we got over here. So this is yet another way you could figure all of this stuff out. All these methods, hopefully I'm not being too scatterbrained when I'm explaining all these processes here, but they're all different ways of doing the same thing. And really, if you know one of them, that's enough, but there's a lot of different ideas that are interconnected, and they all have their usefulness. And that's how math is a lot of the time. Sometimes there's an easy way to do something, sometimes there's a hard way. The hard way is usually easier to remember, and the easy way is usually harder to remember. So it's kind of backwards in that way, just as things. Now let's apply the vertex formula just to double check with G and H to make sure that those vertices also come through. That's the plural of vertex, by the way. Vertices, usually you don't have more than one, because in a quadratic function there's only one vertex. There's not multiples. But anyways, so let's check it with the formula. So let's try it the other way using the my dog's distracting me, sorry. Using the other trick I was mentioning before, which is basically, it's a little simpler, I think. But you still start with the same thing. You first need to figure out what is negative b over 2a. So in this case, we have negative b is negative 6, and 2a is negative 6 as well. So a triple negative would be negative still. So what that would leave me with is positive 1 for the x location of the vertex. No, triple negative, sorry, negative 1. And then the question is, well, what's the k location of the vertex? And again, I could use this, but let's pretend that we forgot this formula, because it's a little bit more complicated than negative b over 2a. But one of the nice things about a function, to recap, is that if we know the x location, we can always find the y location by plugging it in the function, right? Because that's how a function works. Input, output, predictability defined by the formula. So basically, if I were to plug in g of -1, that would be an alternative way of getting the y coordinate for the vertex k. So, and let's just make sure that works. And so far we've confirmed, because when we solved it by completing the square, we got this as a vertex. And since we got the same x coordinate, that should be, good, as expected. So if we were to plug in -1, that would be -1 squared is positive 1, so that would be -3 times 1 is -3. Then -6 times -1 is +6 plus 24. And that would end up being 30 minus 3, or 27. And so we could check ourselves. And ultimately, this is a way that on an exam or whatever, if you wanted to say, how can I make sure I get the vertex right? Well, there's another way. But usually what I suggest is graph it. That's obviously doesn't take much thinking. But there is a weakness of graphing it, which I wanted to demonstrate. So let's go ahead and graph g of x with a calculator. And that is, of course, that sometimes when you graph it, you can't see the vertex because it's not in your viewing window. So you can always change your view window to try to say, like when I'm just eyeballing this, I can tell that I have this sort of parabolic shape, and so the vertex is somewhere up here. So what I could do is extend the range and increase, well, what's the y max? Say, and since I already know that it's up near 30, I could just set it to 30. But basically, you can kind of guess and check until you see where the location of the vertex is. Or, of course, you could trace, as I think I showed in a previous video, by hit trace, type in the -1, and go to that point to see, well, is that correct? Does that work? And, there's another way. So lots and lots of different methods for finding the vertex. And I'll let you verify that the vertex formula works for this one as well.